There we go. Okay, so infinity homework due tonight, chain rule, number 5. Okay, so we're gonna start with one like this. I'm calling this putting it all together because you gotta use all the rules you know to solve these kinds of things, okay? So now we're at the point where we use all the rules we know. And remember, I sort of gave you the hint of the chain rule should be something that you do just instinctively, like you should always try to use the chain rule. And if you don't need it, you're not gonna cause yourself any extra work. But you should always be thinking, does the chain rule apply in this question? So I have two functions, x to the 6 plus 1 all raised to the 5th, and 4x plus 7 all raised to the 3rd. Those two functions are multiplied together. To take the derivative of this guy, what do I need? I need a chain rule. What else do I need? A product rule. I need a product rule to take the derivative of this guy. The power rule, yep. The power rule will be like the chain rule part. So I'm going to call this guy x to the 6th plus 1 to the 5th, my first function f. And this guy 4x plus 7 to the 3rd, my g. The product rule says f prime g plus f g prime. So I need the derivative of that pink function. The derivative of that pink function is 5, leave the inside alone, to the 4th, times the derivative of the inside. So the derivative of the stuff inside that pink function, x to the 6th plus 1, is 6x to the 5th. Times the second function, so times g. Plus, now I'm going to do the second piece of my product rule. First, x to the 6th plus 1 to the 5th, times the derivative of the second. So I'm taking the derivative of this green function, 4x plus 7 cubed. So the derivative of something cubed is 3 times something squared. Remember, whatever's inside that function stays inside your parentheses. You don't change it at all. 4x plus 7 times the derivative of the inside. So the derivative of that 4x plus 7 is 4. I think on your homework, you then had to plug some numbers into these kinds of things. So I would type it into Desmos just as I see it here and replace all my x's with whatever numbers they give you.
Right. Times 4x plus 3 squared to the 3rd to the middle.
So this was f prime times g
Oh, yeah.
plus f times g prime. Make sure if your number is negative that you're plugging in, you put some parentheses. The 4 at the end comes from the derivative of this inside part. The derivative of 4x plus 7 makes the 4. Yeah, that's in this 6x to the 5th comes from the derivative of that inside part there. I use the chain rule by putting these guys, these derivatives at the end, this 6x to the 5th and the 4, because I did bring the power in front, keep the inside the same, subtract 1 from the power, multiply by the derivative of the inside. That's what the chain rule says. So that these pieces here that are underlined are the chain rule parts. Okay, let's try again. This guy says cosine x over 1 minus sine x all squared. So cosine x over 1 minus sine x all squared. So what kind of rules do you think you're going to need for this guy? A quotient and a power rule, right? Quotient because inside here you have two things divided, right? So I need a quotient rule. And then power rule or chain rule because you have something raised to the second. So when I do the derivative of this kind of thing, this is like my inside piece. This cosine x over 1 minus sine x is my inside function. When I take the derivative of that inside function, I need the quotient rule. So quotient rule. So I'm going to do the chain rule because I have something, the green stuff squared. The derivative of something, the green stuff squared, is 2 times something to the first. That something inside here, though, doesn't change. I'm still putting cosine x over 1 minus sine x inside there. Okay, times what has to go at the end here? The derivative of the green stuff. The derivative using the quotient rule. So the quotient rule says what? Yeah, derivative of the top times the bottom. So 1 minus sine x times the derivative of cosine. What's the derivative of cosine? Negative sine minus top times the derivative of the bottom. So derivative of 1 is 0. Derivative of negative sine is negative cosine all over the bottom function squared. You can leave it like that. You can simplify if you want to. You don't have to though. So if you want to, you can be done and leave it like that. If you simplify, I think this is going to simplify nicely because you have a positive cosine squared and a positive sine squared. And when you do sine squared plus cosine squared, you get 1. So they're going to go away, but it's not necessary. You can be done at that point. But if you want to, you could simplify. So all the rules we know, the power rule, the product rule, the quotient rule, the chain rule, they're all happening at the same time, right? You can't like keep them out in their own little bubbles. They have to all be able to work together. So I started by having an inside function that needed the quotient rule raised to a power. So I started by doing the outside most function. In this case, the outside most function was that square. The derivative of something squared is put the 2 in front, subtract 1 from the power. Notice that the inside didn't change. Then I multiplied by the derivative of the inside. In this case, the derivative of the inside was really hard, right? In the previous example I didn't have to do that. I had like 2 pieces and I used the product rule first. And inside the product rule, I choose the chain rule. Okay. Here's one that doesn't give us the equations, right? So this doesn't tell us what our function f and g are. This just tells us things about our functions f and g. And it gives us new functions, and it says, find the derivative at a for these given functions. Okay, so all of these tables of information is about f and g. So for instance, this -2 here tells me that when x is 1, the derivative of f is -2. So this -2 tells me f prime of 1 is -2. If I ever need f prime of 1, I'm going to replace it with a -2. So we're going to start by just trying to take the derivative of these 2 functions, okay? And what you notice about these 2 functions is they have outsides and insides. Yeah, everybody see that? These 2 functions both have outsides and insides. So what rule do I need to take the derivative of these functions? Chain rule. Okay, so h prime of x is derivative of the outside, f prime. Leave that inside function alone, right? Don't change him. G of x times, so close, g prime of x. So before I plug in any numbers, I'm just going to take both derivatives, okay? So I took the derivative of this first function, f of g of x. My outside function was f, my inside function was g. I do derivative of the outside, leave the inside alone, times the derivative of the inside. Okay, what do you say about this second function? What would you say the outside function is? Yeah, x to the -2, right? Raising to the -2 is the outside function in this second piece. Raising to the -2 is the outside function. The inside function is the x to the 4th plus g of x. So to take the derivative of this guy, I say derivative of the outside. bring the -2 in front, and subtract 1 from the power. So what should go up here? -3, good. The inside though doesn't change. You just put that inside down. X to the 4th plus g of x times, what goes at the end? 4x to the 3rd plus g prime of x, good. The derivative of the inside. The derivative of x to the 4th is 4x to the 3rd. The derivative of g of x is g prime of x. So at this point, I've done the calculus, right? Like that's all the calculus. The rest of the stuff is just the algebra. This guy says, find the derivative at a equals 0. So I'm going to replace all my x's with zeros. This guy says, find the derivative at a equals 1. So I'm going to replace all my x's with 1s. All the x's, right? This x here is going to get replaced with a 1. This x here is going to get replaced with a 1. This one's going to get replaced with a 1. So all of them are going to get replaced. Okay. H prime of 0 is f prime of g of 0 times g prime of 0. H prime of 1 is -2, 1 to the 4th, g of 1 to the -3rd, 4 times 1 cubed plus g prime of 1. We're going to do that now. Yep. So now all of these things that have f's and g's, we're going to look at the table to find the values. So in this first function, I need to look at the table and find g of 0. I need to look at the table and find g prime of 0. In the second function, I need to look at the table and find g of 1. And I need to look at the table and find g prime of 1. So I'm going to go to the table for those 4 values. G of 0 for right here. G prime of 0. G of 1 and g prime of 1. Okay, so go look at the table for those 4 values. I'm going to make it a little bit smaller while I look at the table. And get some colors. Let's see, let's start with pink. G of 0. Here's 0, here's G, 0. That was good. Blue, G prime of 0. Here's 0, here's G prime, 2. Good. Yellow, G of 1. Here's 1, here's G, 3. And last but not least, G prime of 1. Here's 1, here's G prime, 0. Okay, so I'm plugging those numbers in. F prime of the pink number, G of 0 was 0, times the blue number, 2, and H prime of 1, -2 times 1 to the 4th is 1, so I'm going to write 1 here. G of 1, the yellow one was 3 to the -3rd. 4 times 1 makes 4. G prime of 1 was 0. Okay, do I need to go back to the table at all?
Yeah.
Yeah. I need to go back to the table because I still have this f prime of 0, right? Anytime I don't have just numbers and I have those functions, I gotta go back to the table. I have to go back to the table one more time and look for f prime of 0. So when I go back to the table to look for f prime of 0, I see that here's the 0, 5. Good, okay. So I have, almost out of space. 5 times 2, 10. This one is -2 times 4 to the -3 times 4. -1/16. Maybe. Someone should check that in their calculator. What happened to the 2? I lost it. The 2. So -1/8. I lost the 2. I brought him back though, so it's okay. Oh man. Oh, it says I am sharing. Okay, good. I was afraid I forgot to share my screen. Okay, we're gonna do now this whodunit activity. Right, it's gonna be good. Let me show you how it Control click, did that. There we go. So I'm going to show you how it works. And then you can scan this QR code and it'll take you right there. So you won't be able to write on these pages. So basically there's a bunch of stuff here. It's kind of like Clue, right? You're trying to figure out who did it. So what you'll do is you'll go through and you'll solve all of these clues by taking the derivative. So you'll find the derivative of this function. Whichever answer you find eliminates something from that main list. So if you say that this one is the derivative, then the victim was not electrocuted. So up here, you'll be able to put an X under electrocution, okay? After you solve all the clues, you should have one person that didn't get eliminated, one place that didn't get eliminated, and one method that didn't get eliminated. At the end of this, there is a QR code or a link, like you could click the link in your phone or whatever, to enter your answer. Maybe. There's a QR code for you to enter your answer. So you can type names in here if you want. You click the people you think it is. So if you think that it was Professor Delta in the gym with a stubbed toe, you would click submit. It'll say whether you can view your accuracy, and it'll tell you how you did. I did really badly because I didn't know. Apparently it's not Professor Delta. Okay, so there are 10 clues. So there are 10 derivatives for you to take. You just take the derivative, you match it to what's here, and you use that clue to eliminate something. Okay, you can work as teams. And like, let's say at 1:25, I'll start homework questions, okay? So I'll walk around and help. You work as teams. I'm gonna put the QR code back up. You can, yeah, you can all work together. I don't care. So here's the QR code so that you can get to the activity, okay? Zoom recording. Oh, you guys. Okay, so here we go. I'm going to do some homework questions. We've got 24 minutes. Let's see if I can do them all. My test. This is question 5. Find the derivative of natural log of the cube root of x. Before I find the derivative of natural log of the cube root of x, I'm going to rewrite it so that all the pieces look like things I can find the derivative of. Cube root of x is the same as x to what power? 1/3. Okay. Derivative of natural log of stuff is
1 over that.
1 over stuff times the derivative of that stuff. So 1/3 x negative 2/3. Perfect. So the derivative of natural log of a whole bunch of stuff is 1 over that stuff. Whatever that stuff is, you got to put all that stuff underneath there in the bottom. Times 1/3 x to the negative 2/3. I did 1/3 minus 1. Yep. Well, no, Mohammed did 1/3 minus 1.
Are you recording?
I think I'm recording.
Just like later.
Yes. It says I'm recording. So we're good. Okay, let's see what's next. 12. 12 is next. Find the derivative of this guy. Oh, man. What do I need to do the derivative of that guy? The product rule. Anytime I have two things with variables in it multiplied together, I need to use the product rule. So for number 12, I'm going to need the product rule. Product rule says derivative of the first. So my first function is t to the 4th plus 7t. My second function is 1 minus e to the negative 4t. So derivative of the first, 4t cubed plus 7 times the second, 1 minus e to the negative 4t, plus first, t to the 4th plus 7t, times the derivative of the second. Derivative of 1 is 0. Derivative of e to something, e to the something, times the derivative of that something. So I need the derivative of this negative 4t. So times negative 4. Okay. So the chain rule should always be in your head. Whenever that something, whenever that exponent of e is not just x, you're going to multiply by its derivative at the end. The chain rule should always, always happen. Okay. 12. Who remembers what's next? 13? Yeah, I think this is 13. 13. Oh, I'm going to rewrite this guy before I take the derivative. What am I going to make him look like? All that stuff to the 1/2. What rule do I need? I need the quotient rule because this derivative inside piece is a fraction, right? And there's no way for me to fix it like there was on that whodunit. I can't. When there's x's in the top and the bottom, you're not going to get around the quotient rule. Okay, so but that's the inside piece, right?
Yeah.
So when I take the derivative of the inside piece, I'm going to use the quotient rule. So I'm going to say something to the 1/2 is 1/2 something to the negative 1/2. That inside function doesn't change at all. Times. I'm going to put a whole big bunch of parentheses because over here, I need the quotient rule. Quotient rule says bottom 2 minus cosine x times the derivative of the top. The derivative of 9 minus sine x is 0 minus cosine x. So negative cosine x minus top 9 minus sine x times the derivative of the bottom. Derivative of 2 is 0. Derivative of negative cosine is positive sine. Yeah, because I get 2 negatives, right? So positive sine x all over 2 minus cosine x squared. If you use parentheses exactly as I have parentheses, you should be able to enter it in just like this. Make sure not to lose these big brackets on the outside. Make sure this whole thing has the line under it, and you should be able to enter it in there just like that. I got the positive sine x by taking the derivative of negative cosine. Because the derivative of cosine is negative sine, but then I have a negative there. So negative negative makes positive sine x. Okay. 16. Suppose f of t is this function here. Find the derivative. Ooh, this is like the one on the whodunit. I would rewrite this first. What can you rewrite this as? Yeah, negative 1/2. 1/2 because it's a square root. Negative because you brought it from the denominator to the numerator. So 6 times t minus 9 to the negative 1/2. To take the derivative, I'm going to bring the power in front. 6 times negative 1/2 is negative 3. T minus 9 to the negative 1/2 minus 1, negative 3/2 times, what's the derivative of the inside? 1. Yeah. Okay, so that's what's going to go here. Negative 3 t minus 9 to the negative 3/2. Find an equation for the tangent line at this point 34, 6/5. So if my point is 34, 6/5, how am I going to find my slope? Yeah, plug 34 for t into the derivative. So I'm going to use this derivative function. I'm going to take my slope to be negative 3 times 34 minus 9 to the negative 3/2. Negative 3 over 125. I don't know, someone should put that in their calculator. 34 minus 9 is 25. Square root of 25 is 5. Cubed is 125. Put it in the denominator. I'm confident now. Okay, I need the equation of the line though, right? What are my two variables in this equation? Y and T, yeah? So make sure that your equation has a T in it and not an X. So we're gonna say Y minus 6/5 is M, negative 3 over 125 times X, not X, T minus 34. Okay, because I'm using T's and not X's. Let me make that look more like a T and less like an X. T minus 34. And that all comes from this f of t, right here, okay? So that comes from that f of t right there. I need to get y equals. You see how it says y equals here? So add 6/5 to both sides. -3 over 125, t minus 34 plus 6 over 5. I think you can enter it like that. If you want to, you can distribute and combine like terms, but I think it'll take it in just like that guy. So I had the derivative, I found the slope by plugging in my number, and then I did this point slope form. I did the, point slope form to get the equation of that line. Okay. Okay, 18. Oh. Capital F is this guy. And capital G is this guy. Yuck. And you know all these things. Okay, it says find capital F prime of 4. How do you take the derivative of capital F? How do you take the derivative of this guy? Whoa.
You would take the derivative of F.
So you need the chain rule, yeah? So we're going to say derivative of the outside, F prime, leave the inside alone, times the derivative of the inside, F prime. Yeah. How do I take the derivative of G? This is G. Bring the 2 in front. 2 times f of x to the 1 times f prime of x. Yeah. So look, in here, I'm going to need to use this answer there. Crazy, right? Okay, so let's do this part first. Capital F prime of 4. Capital F prime of 4. Here's my f prime. So that's little f prime of f of 4 times f prime of 4. So when I'm looking at my pieces, this guy is 6. And this guy is 12. So this is f prime of 12 times 6. Look, this still has an f in it, right? So I need to go back to the list up there. This guy is 5. So 5 times 6 or 30. So for this G part, there's 2 ways to do it. We can use this formula that we just got, 2 capital F of 4 times capital F prime of 4, right? Or we can take the things we know about capital F and plug them in there. Doesn't matter, okay? So you can do it 2 ways. Let's go with it as capital G and see how it goes. G prime of 4 is 2 capital F of 4 to the first times capital F prime of 4. This thing is what I just found in the last answer, right? Yeah. So that guy's 30. This thing, F of 4, I have to use that other formula. Remember it was F of 4, like this. So I have to use F of, I got to go up to my list to find F of 4. It was 12, if you remember. And F of 12, I go up to my list to find F of 12. F of 12 is 3. So this guy's going to be 3. So in here is 3. So 2 times 3 times 30, 180. That one was hard because we had to use like a function inside a function inside a function. That was not fun at all. Okay, let's see. 19. Oh, this one's easier, I promise. If you want to take the derivative of h, how would you write him?
5 times 3 f of x to the
Perfect. 5 plus 3f of x to the 1/2. And now I'm going to use which rule? Chain rule, yeah. H prime of x is all of this stuff to the 1/2. Derivative of a whole bunch of stuff to the 1/2 is 1/2,
Wait, what?
whole bunch of stuff
Oh,
to the negative 1/2 times what goes at the end? Derivative of that yellow stuff.
so
Okay, derivative of 5 is 0. Derivative of 3f is 3f prime. Yeah, so 3f prime. Okay, I want to find it at 1. So for all of the x's, I'm plugging in a 1. So h prime of 1 is 1/2. 5 plus 3 times f of 1 to the negative 1/2 times 3f prime of 1. So I go to my list and I know that f prime of 1 is 2 and f of 1 is 7. So 1/2 5 plus 3 times 7 to the negative 1/2 times 3 times 2. Some number. 3 over square root 26. Some number. 3 times 7 is 21 plus 5 is 26. This is square root in the bottom. 2's cancel, I'll leave a 3, but you could just get that decimal, right? Put this in Desmos, get that decimal. Okay, I think I got one more. People are writing still. Let me let you write. Find the equation of the tangent line to this curve at the point 4, 0. Okay, if I know the point is 4, 0, then to find the slope, what do I do? Plug in 4 into what? Not the equation. In the derivative, yeah? To find the slope, you plug 4 in the derivative. So I have to start by taking the derivative of this guy. Okay, derivative of natural log of something is 1 over something. Good. This was negative in the front, so negative 1 over something times the derivative of the inside, 3x squared. Okay, to find the slope, I'm going to plug 4 into this number, into this equation, sorry. Negative 1 over 4 cubed minus 63 times 3 times 4 squared. Negative 48. Okay, I need the equation of the tangent line. Here's my slope, negative 48. Here's my point, 4, 0. I write the equation, y minus 0 is m negative 48 times x minus 4. That guy goes away. Y is negative 48 times x minus 4. I have 7 minutes left. Do you guys need any more homework questions? Jake's like, nope. I'm gonna go home and start it.
me too.
You too?
I did like 3.
Not me. Okay, wait, let me stop this.